Git Architecture. This is an architectural diagram of Git. Git is software for tracking changes in any set of files, usually used for coordinating work among programmers collaboratively, developing source code during software development. Its goals include speed, data integrity, and support for distributed, nonlinear workflows. Thousands of parallel branches running on different systems. Now we are focusing on working tree. The working tree is the current tree on which we are working. It's where our unstaged changes are kept. Git object model is built around files, trees, commits, and references. A tree can be seen as a directory which link files blob. Here you can see the content structure of sample Git data. Here in staging area now has two new version of test file and as well as the new file new.txt. Notice that this tree has both file entries and also test.txt. SHA-1 is the version 2 SHA-14 from earlier. Just for fun, we'll add the first tree as a subdirectory to this one. You can read trees into a staging area by calling git read-tree. In this case, you can read an existing tree into a staging area as a subtree by using the -- prefix option in with this command. If you created a working directory from the new tree you just wrote, you would get the two files in the top level of the working directory. And a subdirectory name BAK that contains the first version of the test.txt file. You can think of data that Git contain for these structures as been like this. As an example, we can consider this Git work tree manage multiple working trees attached to the same repository. Git work tree list details of each working tree. The main working tree is listed first, followed by each of the linked working trees. The output details include whether the working tree is bare, the revision currently checked out, the branch currently checked out or detached head if none, locked if the work tree is locked, prunable if the work tree can be pruned by prune command. We can consider this error as an example. Fatal. This operation must be run in a work tree. For example, this occurred in Git checkout version 2.0. Now we are focusing on staging area. Staging area is files that are going to be a part of the next commit, which lets Git know what changes in the file are going to occur for the next commit. It selects and retrieves instruction from the main memory in proper sequence and interpret them so as to activate the other functional elements of the system at the appropriate moment to perform their respective operations. Here you can see the life cycle of the status of your files. At this point, you should have a bona fide Git repository on your local machine and the checkout or working copy of all of its files in front of you. Typically, you will want to start making changes and committing snapshots of those changes into your repository each time the project reaches a state you want to record. Remember that each file in your working directory can be in one of two states, tracked and untracked. Tracked files are files that were in the last snapshot as well as any newly staged files. They can be unmodified, modified, or staged. In short, track files are files that Git knows about. Untracked files are everything else, any files in your working directory that were not in your last snapshot and are not in your staging area. When you first clone repository, all of your files will be tracked and unmodified because Git just checked them out and you haven't edited anything. As you edit files, Git sees them as modified because you have changed them since your last commit. As you work, you selectively stage these modified files and then commit all those stage changes and the cycle repeat. Here you can see untracked, unmodified, modified and stage. Add the file is passed from untracked to stage. Edit the file is passed from unmodified to modified. stage the file is passed from modified to stage. Commit is passed from stage to unmodified. Remove the file is passed from unmodified to untracked. Here you can see staging area commands. With the staging area, there is one middle point before commits. Files can be untracked, modified, staged, and commit or committed, and we have a variety of commands to go between states. Git add path stages all changes in file. Git add -p path stages while letting you choose which lines to take. Git commit commits the stage change. Git diff see unstaged changes. Git diff --stage its stage changes. Git rm removes a file. Git reset unstages stage changes. In latest git restore --staged path. Git checkout path check out the latest stage version or committed version if the file has not been signed. In the latest git restore path. We can consider here one usage. You do various things at once. You want to commit them separately. Git add all the parts of each change. Git diff and git diff --stage to ensure you have all the parts. Git commit and repeat. And another usage, you want to checkpoint. You want to show in progress work before you make a final commit. Git add every change that improves the code. Git checkout every change that made things worse. Git commit as soon as you have created a nice self-contained unit, not too large, not too small. Note the staging area has also alternatively been referred to as the index and the cache. Here you can see working directory and committed. Commit is passed from working directory to committed. Diff head and checkout are passed from committed to working directory. Here you can see staged. Add is passed from working directory to stage. Diff and checkout are passed from stage to working directory. Commit is passed from stage to committed. Diff --stage and reset are passed from committed to staged. Here working directory interacts with committed, and working directory interacts with stage interacts with committed. As an example, we can consider this git add readme. Git add file contents to the index. This command updates the index using the current content found in the working tree to prepare the content stage for the next commit. It typically adds the current content of existing path as a whole, but with some options. It can also be used to add content with only part of the changes made to the working directory file, working tree files applied, or remove paths that do not exist in the working tree anymore. As an example, here we can consider these error messages. Error unable to create temporary file, no such file or directory. Error next folder / some file .txt failed to insert into database. Error unable to index file next folder / some file .txt. Fatal, adding files failed. This error occurred in Git for Windows version 2.22.0.Windows.1. Now we are focusing on local repository. Git local repository is the one on which we will make local changes. Typically, this local repository is on our computer. Here we are considering a special case, Git platform architecture. Git is a distributed version control system. It means developers can share code from their workstation to others without the need of any centralized repository. However, at DBI-services, they made the choice to deploy a centralized repository platform. First, in order to avoid manual synchronization between all developers, then to benefit a shared common collaboration platform like GitHub or GitLab. Prior to being allowed to make a push request to the centralized repository, a developer must first ensure having got latest source code revision into its local workstation repository pull request. Then he can commit locally his changes, eventually correct merge conflict, finally make the full request, finally make the push request to centralized platform. Here you can see Git platform shared repository. Inside it there's a shared repository and push and pull is here. Now here you can see developer 1. Inside that local repository is there and working copies are here, and local commit is here, and developer 2 local repository and working copy, and there's a local commit. As an example, we can consider this. This is to start a new Git repository for an existing code base. Here in Git init, create a path create a /path /2 /my /codebase /git directory. In Git add all existing file to the index, and here Git commit, record the pristine state as the first commit in the history. Here in Git init, create an empty Git repository or reinitialize an existing one. This command creates an empty Git repository, basically a git directory with subdirectories for object, refs, heads, refs tags, and template files. An initial branch without any commits will be created. As an error example, we can consider this one: fatal, not a Git repository or any of parent directories .git. Git determines whether you are in a Git repository by looking for a specific hidden folder in the current directory or one of its parents. This folder is aptly named .git. If present, this folder should be in the root of your project tree. If Git can't locate this folder from the directory you issued the git command in, it will throw the above error. Now we are focusing on remote repository. Remote repositories are versions of your project that are hosted on the internet or network somewhere. You can have several of them, each of which generally is either read-only or read-write for you. Collaborating with others involves managing these remote repositories and pushing and pulling data to and from them when you need to share work. Managing remote repositories include knowing how to add remote repositories, remove remotes that are no longer valid, manage various remote branches and define them as being tracked or not, and more. Here you can see distributed version control system. Distributed systems are those which allow users to perform work on a project from all over the world. Generally, a distributed system holds a central repository that can be accessed by many remote collaborators by using a version control system. Git is one of the most popular version control system that is being used in nowadays. Having a central repository result in a problem of data lost or data disconnectivity in case of a system failure of the central server. To tackle such kind of situation, Git mirrors the whole repository on each snapshot of the version that's been pulled by the user. In this case, if the central server crashes, then copy of the repositories can be gained back from the users who have downloaded the latest snapshot of the project. Having a distributed system, Git allows users to work simultaneously on the same project without interfering with others' work. When a particular user gets done with their part of the code, they push the changes to the repository, and these changes get updated in the local copy of every other remote user, which pulls data, which pulls the latest copy of the project. Here you can see local repositories here and marked as workstation, and commit is passed from workstation to Git, and push is passed from Git to Git hub, and pull is passed from Git hub to Git, and updation is there. And here also commit is passed from workstation to Git, and push is passed from Git to Git hub, and pull is passed from GitHub to Git and updations here. Here also commit is passed from workstation to Git and push is passed from Git to Git hub, and pull is passed from GitHub to Git and updations here. And this is the remote repository Git hub, and here GitHub interact with Git and Git interact with workstation. Here also Git interact with GitHub interact with Git and Git interact with workstation, and here also GitHub interact with Git and Git interact with workstation. These are the local repository. As an example, we can consider this one git remote at pb/https://github.com/paulboon/ticket. Here in git remote, manage the set of repositories remotes whose branches you track. Git remote add the remote name for the repository at URL. The command git fetch name can then be used to create and update remote tracking branches name/branch. Here you can see error example, error repository not found. If you see this error when cloning a repository, it means that the repository does not exist or you do not have permission to access it. Now we are focusing on new repo. To create a new repo, you will use the git init command. Git init is a one-time command you use during the initial setup of a new repo. Executing this command will create a new .git subdirectory in your current working directory. This will also create a new main branch. Here you can see the git init bare repositories. A shared repository, the shared repositories must be created with the --bare flag. The --bare flag is used to create repository that has not working directory and does not allow editing files and commit changes in the directory. --bare is a way to mark a repository as a storage facility. Bare repository must be initialized to git push and git pull, but never directly commit to it. Central repositories must be created as bare repositories because pushing branches to non-bare repository can overwrite changes. The central repository is always bare, while the local repositories are non-bare. Most common use for git init --bare is creating a remote central repository. Moving to local report. Checkout is passed from local report to working tree. rm --cache reset head are passed from staging area to working tree. Here in staging area and working tree, the status can be unmodified, added, modified, deleted, renamed, copied, updated, but merged. Here you can see the fork repository, and remote repository interacts with fork repository. A fork is passed from remote repository to a fork repository. Pull request is passed from here fork repositories to remote repository. Remote is moving to remote repository. And clone, init, pull, fetch, merge are passing from remote repository to local repository and working tree. Fetch is passed from remote repository to local repo, and merge is passing from local repo to working tree. Here working tree interacts with staging area. Staging area is connected to local repo. Local repo interacts with remote repo. Local repo is connected to connected to working tree here, and remote repo is remote repo interacts with forked repo here. As an example, we can consider this here. This is to start a new Git repository for an existing code base. Here in Git init, create a /path/2/my/codebase/git directory. Add an existing files to the index. Here git add dot and git commit. Record the pristine state as the first commit in the history. Here in git init, create an empty git repository or initialize an existing one. This command creates an empty git repository, basically a .git directory with subdirectories for objects, refs heads, refs tags, and template files. An initial branch without any commits will be created. As an example, we can consider this one. Fatal, not a git repository. This error means you attempted to run a git command but weren't inside a git repository. Make sure you have navigated to the right directory. Check with ls. Initialize your repository with git init or by cloning an existing repo. Usually this is enough to fix the error. As an example too, we can consider this. Clone from upstream. Git clone a repository into a new directory. Clone a repository into a newly created directory. Create remote tracking branches for each branch in the cloned repository, visible using git branch -- remotes, and creates and checks out an initial branch that is forked from the cloned repository's currently active branch. As an example we can consider this error, repository not found. If you see this error when cloning a repository, it means that the repository does not exist or you do not have permission to access it. Now we are focusing on update. Here you can see git pull and how it works. The git pull command first run git fetch, which download content from the specified remote repository. Then git merge is executed to merge the remote content refs and the heads into new local merge commit to better demonstrate the pull and merging process. Let us consider the following example here. Assume we have a repository with main branch and remote and a remote origin. In this scenario, Git pull will download all the changes from the point where the local and main diverged. In this example, that point is E. Get pull will fetch the diverged remote commit, which are A, B, C. The pull process then create a new local merge commit containing the content of the new diverged remote commits. In this diagram, we can see the new commit H. This commit is the new merge commit that contains the contents of remote A, B, C commits and has combined log message. This example is one of a few Git pull merging strategies. A rebase option can be passed to Git pull to use a rebase merging strategy instead of merge commit. In this example, we'll demonstrate how to rebase pull works. Assume that we are at the starting point of this diagram here, and we have executed git pull -- rebase. In this diagram, we can now see that a rebase pull does not create the new H commit. Instead, the rebase has copied the remote commits A, B, C and rewritten the local commits E, F, G to appear after them in the local origin main commit history. Here we are considering synchronize origin with git fetch, and this command git fetch origin here we work through the typical workflow for synchronizing your local repository with central repository's main branch. The command here we are considering is git fetch origin, and this will display the branches that were downloaded in this example here. The commits from new remote branches are shown as squares instead of circles in the diagram here. You can see git fetch gives you access to the entire branch structure of another repository. You can see main here and origin main here and origin develop here and origin some features here. Example, we can consider this git pull and git pull origin. This update the remote tracking branches for the repository you cloned from, then merge one of them into your current branch. Git pull fetch from and navigate with another repository or a local branch, incorporates changes from a remote repository into current branch. If the current branch is behind the remote, then by default it will fast forward the current branch to match the remote. If the current branch and the remote have diverged, the user needs to specify how to reconcile the diverged branches with dash dash rebase or dash dash no dash rebase or the corresponding configuration option in pull dot rebase. As an error example, we can consider this error untracked working tree file nb project /private /rec -d.txt would be overwritten by merge aborting. This error occurred in git pull origin master. As an example too, we can consider git fetch origin, update the remote tracking branches. The above this command copies all branches from the remote refs heads namespace and stores them to the local refs remote's origin namespace unless the branch name.fetch option is used to specify a non-default ref spec. Git fetch branches and or tags collectively refs from one or more other repositories along with the objects necessary to complete their histories. Remote tracking branches are updated. Here we can consider this as this warning. Warning: git fetch failed with exit code 128 back off 7.364 seconds before retry. This is occurred in Azure DevOps service. Now we are focusing on changes. When working with Git or other version control systems, the concept of saving is more nuanced process than saving in a word processor or other traditional file editing applications. The traditional software expression of saving is synonymous with the Git term committing. A commit is the Git equivalent of a save. Traditional saving should be thought of as a file system operation that is used to overwrite an existing file or write a new file. Alternatively, Git committing is an operation that acts upon a collection of files and directories. Here you can see it is possible to jump over the stage and check out files directly from the history or commit files without staging first. Git commit -a is equivalent to running git add on all file names that existed in the latest commit and then running git commit. Git commit files creates a new commit containing the contents of the latest commit plus a snapshot of files taken from the working directory. Additionally, files are copied to the stage. Git checkout head -- files copies files from the latest commit to both the stage and the working directory. Here you can see working directory, stage or index and history. Here you can see git commit files go to stage and history, and here you can see git checkout head -- files is passed from history to stage and working directory. Here you can see git add and how it works. Git add command should not be confused with svn add, which adds a file to the repository. Instead, git add works on the remote abstract level changes. This means that git add needs to be called every time you alter a file, whereas svn add only needs to be called once for each file. This may sound redundant, but this workflow makes it much easier to keep the project organized. Here you can see the four commands above copy files between working directory, stage, also called index, and history in the form of commits. In Git add files, copies files at their current state to stage, and Git commit saves snapshot of the stage as a commit, and Git reset -- files unstages files, that is, it copies files from the latest commit to the stage. Use this command to undo git add files. You can you can also git reset to unstage everything, and git checkout -- files copies files from the stage to working directory. Use this to throw away local changes. You can also use git reset -p, git checkout -p, or git add -p instead of or in addition to specifying particular files. Interactively choose which hunks copy. So here you can see working directory, stage, index, history. Git add files is passed from working directory to stage. Git commit is passed from stage to history. Git reset -- files is passed from history to stage. Git checkout -- files is passed from stage to working directory. Here you can see git commit snapshots, not differences. Here you can see recording file diffs in SVN. Here you can see recording snapshot in Git. Aside from the practical distinctions between SVN and Git, their underlying implementation also follows entirely divergent design philosophies. Whereas SVN tracks differences of a file, Git version control model is based on snapshots. For example, SVN commits consist of a diff compared to the original file added to the repository. Git, on the other hand, records the entire content of each file in every commit. This makes many Git operations much faster than SVN, since a particular version of a file doesn't have to be assembled from its diffs. The complete version of each file is immediately available from Git's internal database. Git snapshot model has a far-reaching impact on virtually every aspect of its version control model, affecting everything from its branching and merging tools to its collaboration workflows. Here we are considering git commit. When you commit, Git creates a new commit object using the files from the stage and sets parents to its current commit. It then points the current branch to this new commit. This image here, the current branch is main. Before the command was run, the main pointed to ed489, and then the main was moved to the new commit here. Here we are considering git push origin main. This is before git push origin main here, before pushing and after pushing. Git push is more commonly used to publish and upload local changes to central repository. After a local repository has been modified, a push is executed to share modification with remote team members. This diagram shows what happens when your local main has progressed past the central repository's main, and you publish changes by running git push origin main. Now how git push is essentially the same as running git merge main from inside the remote repository. As an example, we can consider this. The command git commit -a first look at your working tree, notices that you have modified hello.c and removed goodbye.c and perform necessary git add and git rm for you. Here -a or -- all tell the command to automatically stage files that have been modified and deleted, but new files you have not told git about are not affected. As an error example, we can consider this: gvim -f gvim command not found. Error: there was a problem with the editor gvim -f. This error occurred when when git command -a this git commit -a is executed. As an example 2, we can consider git add documentation // this adds contents from all *.txt files under documentation directory and its subdirectories. Note that the asterisk is quoted from the shell in this example. This lets the command include the files from subdirectories of documentation directory / directory. Git git add file contents to the index. This command updates the index using the current content found in the working tree to prepare the content stage for the next commit. It typically adds the current content of existing path as a whole, but with some options it can also be used to add content with only part of the changes made to the working tree files applied, or remove paths that do not exist in the working tree anymore. As an error example 2, we can consider this one: unable to create temporary file, no such file or directory. Error next folder / some file.txt failed to insert into database. Error unable to index file, next folder / some file.txt. Fatal, adding files failed. This error occurred in Git version 2.22.0. Windows 0.1. As an example 3, we can consider this. Instead of staging files after each individual change, you can tell git commit to notice the changes to the files whose contents are tracked in your working tree, and do corresponding git add and git rm for you. Git commit: record changes to the repository, create a new commit containing the current content of the index and the given log message describing the changes. The new commit is a direct child of head, usually the tip of the current branch, and the branch is updated to the point to it, unless the branch is associated with the working tree, in which case head is detached as it's occurred in Git checkout. As another example tree, we can consider this fatal, unable to create /git/index.log file exist. If no other Git process is currently running, this probably means a Git process crashed in this repository earlier. Make sure no other Git process is running and remove the file manually to continue. This error occurred in Git commit. As an example 4, we can consider Git push. Work like Git push remote, where remote is currently where remote is the current branch remote, or origin if no remote is configured for the current branch. Git push update remote refs along with associated object, updates remote refs using local refs while sending objects necessary to complete the given refs. As an error example 4, we can consider this to git at git.assembler.com shabi-s-test.git rejected your branch not fast forward. This means that someone else pushed a commit to the same branch you are pushing to, but you don't have that commit on your laptop laptop or computer yet. This can happen if it has been a while since you ran git pull on a branch that many people contribute to, such as staging. Now we are focusing on Revert. It is first important to note that Git does not have a traditional undo system like those found in a word processing application. It will be beneficial to refrain from mapping Git operation to any traditional undo mental model. Additionally, Git has its own nomenclature for undo operations that it is best to leverage in a discussion. This nomenclature include terms like reset, revert, checkout, clean, and more. Here you can see the use of git reset, revert, git checkout, and squash commit. Here undo undo uncommitted changes using git checkout -- file name. It rollbacks any content changes for those of unspecified those of the specific commit. This will not make changes to the commit history. Use this to move head pointer to a specific commit or switch between branches. Here undo committed changes using git revert. Rollback changes you have committed. Create a new commit from specific commit by inverting it, hence adds a new commit history to the project. It doesn't modify the existing one. Resetting changes using git reset. Use this to return the entire working tree to the last commit state. This will discard commit in a private branch or throw away uncommitted changes. This can be used to unstage a file. This can be a reset soft. This option will reset command will only do one thing: move the head pointer. Reset mixed. This second option of the reset command will do two things: move the head pointer, update the staging area with the content that the head is pointing to. Reset hard. And now for the notorious hard option, running reset -- hard will do three things: move the head pointer, update the staging area with the content that the head is pointing to, updates working directory to match the staging area. Combine commits using squash, a way to group some changes together, especially before sharing them to others. In Git, you can merge several commits into one with powerful interactive rebase. It's a handy tool which can be used quite often. Here you can see Git checkout. Here you can see the Git log dash online sample output, and when you have found a commit reference to the point in the history you want to visit, you can utilize Git checkout command to visit that commit. Git checkout is an easy way to load any of these saved snapshots into your development machine. During the normal course of development, head usually point to main or some other local branch, but when you check out previous commit, head no longer point to a branch. It points directly to a commit. This is called detach head state, and this can be visualized as here. Checking out an old file does not move the head pointer. It remains the same branch and same commit, avoiding detach state. You can then commit old version of the file in a new snapshot as you would any other changes. So in effect, the usage of git checkout on a file serves as a way to revert back to an old version of an individual file. Now we are focusing on detach heads. Here you can see this detach head. Now thus we have seen the git checkout. It's important to discuss detached head state. Remember that the head is Git's way of referring to the current snapshot. Internally, the git checkout command simply updates the head point to either specified branch or commit. When it points to a branch, Git doesn't complain, but when you check out a commit, it switched into a detached head state. This is a warning telling you that everything you are doing is detached from the rest of your project's development. If you were to start developing a feature while in the detached head state, there would be no branch allowing you to get back to it. When inevitably check out other branch, example to merge your feature in, there would be no way to reference your feature. The point is, your development should always take place on a branch, never on a detached head. This makes sure you always have a reference to your new commits. However, if you are just looking at an old commit, it doesn't really matter if you are in a detached head state or not. Here you can see a detached head, and here you can see a attached head here with the main. Here you can see git checkout head title files. When a file name or -p is given, the git copies those files from the given commit to the stage and working directory. Here, for example, git checkout head title foo.c copies the foo.c from the commit called head title the parent of the current commit to working directory and also stages it. If no commit name is given, files are copied from the stage. Note that current branch is not changed. When the file name is not given, but the reference is a local branch, head is moved to the branch. That is, we switch to that branch, and then stage and working directory are set to match the content of that commit. Any files that exist in the new commit, here A47C3 is copied. Any file that exists in the old commit ed489 but not in the new one is deleted. Any file that exists in neither is ignored. Here, when a file name is not given and the reference is not a local branch, say it's a tag, a remote branch, a SHA-1 ID or something like main title 3, we get an anonymous branch called detach head. This is useful for jumping around the history. Say you want to compile version 1.6.1 of Git. You can git checkout version 1.6.1, which is a tag, not a branch, compile, install, and then switch back to another branch, say git checkout main. However, committing works slightly differently with the detach head. As an example, we can consider git checkout head title 2. The above command will check out the grandparent of the current commit. As an error example, we can consider this error path foo/bar.txt is unmerged. Git checkout head foo/bar.txt is the command executed, and then this error was occurred in this particular case. And as an example 2, we can consider this following sequence: check out the master branch, and then reverts the make file to 2 reversions back, delete the hello.c by mistake, and get it back from the index. Git checkout switch branches or restore working free files, updates files in the working tree to match the version in the index or the specific tree. If no path spec were given, git checkout will also update head to set the specific branch as the current branch. As an error example, we can consider this error: your local changes to the following files would be overwritten by checkout. These are the files, and please commit your changes or stash them before you switch branches and aborting. This error occurred in Git checkout master. Now we are considering diff. So show changes between working tree and the index or a tree, changes between the index and a tree, changes between two trees, changes resulting from merge, changes between blob objects, or changes between two files on disk. This is a sample usage of diff command. Note, the diff command will produce the changes in all the files that are present. For changes on some specific files only, type the name of the file after the command space. Now let us break down the response given by Git diff and understand things one by one. First line shows the file names that have been considered as the input in Git diff. You can see that they have been marked by A and B along with the two different file state that has been taken as input. This line is not of use. This shows the metadata related to command and the execution of it on the files. This is the object hash value required by Git for internal use. This line defines the symbol called legend to tell you what is used to describe the first file and what is used to describe the second file. As you see, minus is used in front of the first file and plus is used in front of the second file. So whatever diff shows you the changes related to the first file, they will be marked by minus, and the changes to the second file will be marked by plus. The fourth line shows you symbols ampersand and symbols ahead of it. They are called chunks. Chunks in Git diff define the change summary. Here chunks can be seen as ampersand minus 1, 2 and plus 1 ampersand. This means in 5 this means that the lines 1 and the 2 were changed the first file and the line 1 was changed in the second file. Remember that minus and plus symbols in third point as a symbol to the first and second file respectively. Here you can consider following examples. Here changes in the working tree not yet stage for the next commit. Here changes between the index and your last commit, what you would be committing if you run git commit without -a option. Here changes in the working tree since last commit, what you would be committing if you run git commit -a. Git diff shows changes between commits, commit and working tree, etc. Show changes between the working tree and the index or a tree, changes between the index and a tree, changes between two trees, changes resulting from a merge, changes between two blobs objects, or changes between two files on disk. As an error example, we can consider this fatal ambiguous argument branch _2 branch _1 unknown revision or path not in the working tree. use dash dash to separate path from revisions like this. Git command revision dash dash file. This error occurred under in git diff branch underscore 2 dot dot branch underscore 1. This is the end of my presentation. Thank you very much for watching it.